so again, today, going over our geometric series. Before we talked about our arithmetic sequences, and we learned that they have a common what? Our arithmetic sequences, absolutely, had that common difference. And the difference between a geometric series, or excuse me, geometric sequence, we don't have a common difference, but we actually have a common ratio. So we say that a sequence is geometric if the ratio of the consecutive terms are all the same. So if I do my A2 divided by A1, A3 divided by A2, AN divided by my AN minus 1. If we keep on doing that, and we get that common ratio R, we know we have a geometric series. This is the same thing as when we did what? With our arithmetic series, we did what? Absolutely. Our A2 minus A1, A3 minus A2, and came up with that common difference. Here we're doing division now. Our A2 minus divided by A1, and so forth. So if we have that common ratio, we know that we have ourselves a geometric sequence, and as I just said, R is called the common ratio. If we take a look at that, again, that A2 over A1 equaling R, A3 over A2 equaling R. If I wanted to find A2, absolutely. If I want to find A3. So, with our common difference, with our arithmetic, we always add a D to get to that next term. With my geometric sequence, we do what? Multiply by R. So, here we are on the right. We want to write the first 5 terms of the geometric sequence, where A is equal to 2 and R is equal to 3. Harrison. A1 is 2. So to get to the A2, what do I do again to get to the next term? I multiply by?
102 times 3.
Absolutely. I take that last term and multiply it by my R. So just as you said, 2 times 3 giving us that 6. Okay. For the A3. Absolutely. Multiplying R times our A2 was 6. Giving us our 18. And Aubrey, for our A4. All right, so our 18 times 3. And finally, our A5. Again, all I'm doing is multiplying by R. And what? 62. Once you do this, are we done?
You have to do like A2 over A1.
Check your answer, folks. If you got the time, is it difficult to check our answer here? What would I do to check my answer? Absolutely. See if I still have that common ratio. It told me the common ratio of 3. So if we did it right, our 6 over 2 is 3, 18 over 6, and so forth. Why do we want to do that? Absolutely. Perhaps we did a 2 times 2 or something like that early on, and we said, oh, we messed up here. But so when we check our answer, it didn't take long to do that. We can say, something's wrong here. Let me go back and check. All right, here we have A1 is equal to 5. R is equal to negative 1/10. Evelyn? What do we want to do here? I'm sorry? So R times A1. So our negative 1/10 times 5 Absolutely, giving us that negative 1/2. So here we came up with A2 equaling negative 1/2 to get our A3 and one.
Over 20.
I'm sorry? How'd you get that?
A2
Absolutely. So our negative 1/2 times negative 1/10. Over 20 for our A4. Again, all we're doing at each step is multiplying by negative, actually, we're multiplying by negative 1/10, right? So, and finally our A5 giving us 1 over 2,000. So just like we did before with arithmetic, we're just adding our common difference. In a geometric sequence, all we're doing is multiplying by that common ratio. Yes? So here we want to determine whether or not we have a geometric sequence or not. So in this first one,
Yes.
yeah, I appreciate it. You already knew that way ahead. So 3, 9, 27, 81, how do we know? You say yes.
Not everything. Everything's not going over.
Well, 9 over 3 gave us what?
3.
And then you said what?
27
Absolutely. And if you did 81 over 27, 243 over 81, as Chris said, we come up with that common ratio of 3, so we have ourselves a geometric sequence.
Basically, you can factor it.
Pretty much. Now, what about this next one? I have 3, 12, 21, 30. Is this going to be geometric? This is yours. I know this is Texas. So, what do we do here? Absolutely. So 12 over 3 giving us 4. Does it matter what that equals? We just want to say, does it equal 4? And here it's obvious, as Del said, it does not equal 4. So we know it's not a geometric sequence. Alex, is it an arithmetic sequence?
Yeah.
Absolutely. Absolutely. Here, if we take a look at 12 minus 13, Alex said we gave it 9, 21 minus 12, 30 minus 21. All these have a common difference of 9. It is arithmetic. This does not mean that all sequences must be arithmetic or geometric. It could be neither, that it's just a sequence, neither geometric nor arithmetic. And for this one, C. Okay. How do we start this one off to determine whether or not it is geometric? Absolutely. And when we're dividing by a fraction, you said multiply by the reciprocal. Negative what? Okay, notice that negative 1/4. And then what? What again? From which ones?
64, negative 1 over 64.
Absolutely. Negative 1 over 64 divided by 1 over 16. Once again, right? And we see if we do it with all the other terms as well, our A4 over A3, A5 over A4, we come up with that common ratio of negative 1/4, so this is in fact a geometric sequence. So, just like we did before with our arithmetic, we also had, what if we want to find the 20th term? Or if we want to find the 30th term? We can come up with the nth term of a geometric sequence. So the nth term here we have our a sub n. Not plus. Geometric instead of arithmetic we had a plus. Geometric we do what? Times. We're going to multiply this by our common ratio how many times?
N minus 1.
So it's the n minus 1. Just like we did with our, if you guys remember with the arithmetic, when I went to the difference between my fifth term and my first term. Well, from the first to the second, second to the third, third to the fourth, fourth to the fifth, we've only added up that difference 4 times. Likewise with multiplication, right? I'm not doing anything to get to that first term. The first term is given. So that's 1 less multiplication, right? To go from the first to the third. Well, first to the second, I multiplied by 1r. Second to the third, I multiplied by 2r's. So my r squared. That's why we have that r to the n minus 1 versus r to the n. And again, r was just our common ratio. So every geometric sequence we can write, excuse me, in that form where our a1 times something. So our a2, a1 to the r, our a4, a1 to the a minus 1, so r. Okay, I thought you said 2. Okay, and so forth. So again, at each step, all we're doing is multiplying by r. So if I already know my nth term, I already know what a sub n is, how do I find a sub n plus 1? Add. What do I do to an? Multiply by r. Again, for each, I know what the nth term is. To get that very next term, all we're doing is multiplying by r. Right? If I know the 20th term and I want to find the 21st term, I just go times r. Right? That's what we did in the previous, as far as finding the first 5 terms. Right? We just kept on multiplying by r. So here we want to write the first 5 terms, determine the common ratio, and then write the nth term of the sequence as a function of n. Ashley? So how do I find a2? Here this is recursively defined, right, as far as I had to know a previous term. So for a2, okay, what about it? So for my a2, this tells me how to find it. I let k equal what? If I'm looking for a2, this says ak plus 1. So what does k need to be? 1. 1 plus 1 is 2, right? So that tells me then for a2, I want this to equal 1/2. We just said k was what? 1. So 1/2 of k1, or 1/2 of a1, excuse me. So 1/2 of 64, or just 32. What about for a3? Again, what do I want k to equal now? Okay, absolutely. It's just going to be 1/2 of the previous term, but here we can see, again, that recursive formula tells me a is k plus 1, since I'm looking at a3. K is 2, so as Nicole said, that's just my 1/2 of a2, or just 16. So what are we doing at each step here? Dividing by 2, multiplying by 1/2. So a4 is 8, a5 is. So read, what do I come up with for my common ratio?
Common ratio would be 1/2.
How'd you get that?
I had 4 over 8.
Absolutely, as Reed said, taking a5 over a4. Is that my answer? Are we sure of that? What is that the only thing we should do? Just do one of them and say we're good to go. Exactly. We want to go ahead and do it at least 2 or 3 times as far as we just did a5 over 4. Do a4 over 3, A3 over 2, A2 over A1, a couple of them. Why? Just to kill time. To make sure. We may have made some small calculation error along the way, and you said instead of 1/2, you came up with 1/4. So you knew when you do the next one, 8 over 16, you better come up with that same one. If you did not, go back and check your answer, right? Something went awry. So we have our, as Reed said, we get our R is equal to 1/2. Right now it asks us to find the formula for that nth term. Dominic? If I want to find my A sub n, what am I going to use? I'm going to use times. Absolutely. So what is my A1? Okay. So 64 times to the absolutely. So we wind up with the nth term being 64 times 1/2 to the n minus 1. So now it's no longer recursively defined. I can find the 49th term if I want to without knowing the 48. You substitute in 49 for n, and I come up with that term. Here we have A1 equals 7, AK plus 1 equals 2AK. Maddie? What about A2? Okay, well here it says, if I want to look for A2, what would K equal here? If I want this to equal 2, K would be?
No, sorry. 1.
K would equal 1, right? 1 plus 1 gives me 2. So this tells me I want this to be 2 times A, you just told me K was 1, so 2 times A1. What was A1? So I get my A2 is equal to 14. What about my A3? How'd you get that? Absolutely. Just 2 times my A2, 28. And likewise, all we're doing at each step is multiplying the previous term by its 2. 6 and 12. So, Sean, what about the common ratio?
2.
How'd you get that?
12, 6, 20.
Sean said we come up with 2. Likewise, again, doing 56 over 28, my A4 over A3, my A3 over 2, 28 over 14, 14 over 7. All of those give me that common ratio of 2, right? And so, money. What do we wind up with for our formula for the nth term? Mm-hmm. All right. To the n minus 1, absolutely. So when I said I have my an equals 7, that first term, times the common ratio 2, all raised to the n minus 1.
So with that formula, it's saying, like if we use that formula, A is 17.
I'm sorry?
Okay, if we use that formula, when we just got, like, A, like...
We're going to find like A50.
Or like, because like, if you put 3 in...
A3.
Okay, so then 7, that's 14.
No, this 2 is raised to the n minus 1. The 7 is not raised to that power. Correct.
Oh, okay.
So here I have to the 3 minus 1. 2 squared is 4. 4 times 7 is 28. And same thing as our A3 up there.
So we just given the ratio one through problem.
No, just the ones we've done so far. You're not always going to be given the ratio, no, not at all. So, stuff like, no, this one you're given the ratio. Not like this one. So, Katie, here we have our A1 equals 4, R equals 1/2. n equals 10, and we want to go ahead and find the nth term of the geometric sequence. So, what do we do here?
Before you do the equation, you go a to the 10th equals
Well, first of all, I have to find my nth term. So I need to find my an.
a equals 4. That brings it again.
All right, and then for the indicated term, the 10th term, that's not your final answer, folks.
2048.
What can I do with that power? Can I bring it inside the parentheses? If I have a fraction ratio of power, that's the same thing as what? The numerator raised to that power and the denominator raised to that power. So I have 4 times 1 to the 9th over 2 to the 9th, all right? What is 4? That's 29. Try to simplify where you can, right? Try to cancel out stuff so that at the very end, you don't have to say, okay, you have done just 1 over 2 to the 9th, and then, sure, you could have said, okay, 2 to the 9th is, let's see, 128, 256, 512. So I'd have 1 over 512 times 4, 4 over 512. Now you have to divide. Then come up with 1 over 128. Look for commonalities, right? If you're dealing with 2's, can I transform my coefficients that I have? Can I 2 as well, or something to make it a little bit easier? All right? What about, here we have a1 equals 100, r equals e to the x, n equals 9. And what is my an? For my nth term, right, I need to have n's in there, so my nth term, a to the n equals 100, e to the x, all raised to the n minus 1 power. But then they want us to find the 9th term. So what do we do, Emily? Whenever I see an n, what do I do when I have a power raised to a power? Multiply, giving me, so my 9th term is just 100 e to the 8. That's as far as you're going to go. Question? So here we have, we're going to find the 9th term of the geometric sequence, whose first term is 4, and the common ratio is 1/2. So if I want to find the 9th term, first thing I should find what? Okay. So then finding that 9th term would just be 4 times the 8th power. Does this look familiar? Right there, unfortunately. But that's all right. So we do that exact same process, right? As far as here I can distribute, that's 1 to the 8th power over 2 to the 8th power, and my 4 is just 2 squared. minus 1 over 6. Question? Hmm?
6. So
Six.
it's 2 to 8. And like 2 to 6.
Here, Dorian, we want to find the 10th term of the geometric sequence. So, if I want to find the 10th term, I need to find my a sub n, right? I need to find that formula. So they give us everything we need. Exactly. I need to find that common ratio, and how we're going to do that? Okay, that negative 2 over 6 giving us negative 1/3. And again, I can make sure we did that right with the 2/3 over negative 2. Likewise, we come up with that negative 1/3. So, now we're good. So I got my R. Okay, and we're absolutely. I have my general equation for the nth term. So to find the 9th term, 10th term, my bad. So to find the 10th term, now is where the fun begins, right? Well, first things first, right? Distribute the 9, and also that negative. Is the negative just going to disappear or remain? So I got that negative 6. As Chris said, distribute the 9, so 1 to the 9th power, so 1 over 3 to the 9. Can I do the same thing as I did in the previous problem? So, absolutely. Try to look for commonalities. As Caden said, I can split that 6 into 2 times 3. Since we're dealing with a fraction dealing with the 3 to some power, if I can get a 3, I can actually, it has that understood 1, right? So here we actually have reduced that now to just 1 over 3 to the 8th versus 1 over 3 to the 9th, right? So now I have my negative 2 times 1 over 3 to the 8th. Anybody do this one? Folks, don't expect me to have something like this on the test. I'm not going to test you if you can do 3 to the 8th power, but again, this is the same type of how you want to solve this one. So here we come up with a negative 2 over 6,561. Questions there? And that means, Alejandro, the next problem is all yours. So here, the second term of a geometric sequence is negative 18, and the 5th term is 2/3. We want to find the 6th term. So, what information did they give us? Look at Alejandro's here. Well, they gave me what? Second term is, and what else? So is there a way that I could come up with a common ratio then? Can I write something where, what do I have to do to A2, my second term, to get to the 5th power? Folks, we're all one person working this problem. So, what do I do from A2 to A3? How did I get from A2 to A3? By what? By the ratio. And to get to A3 to A4, what do we do? Multiply by, and A4 to A5. So how many times did we do that? Absolutely. So as Alejandro said, we multiply it 3 times, or R cubed. So now what? We just plug in what we have, our A5. 2/3 equals a negative 18 over r to the third times r to the third power. So folks, what do we do now? Again, dividing, same thing as multiplying by the reciprocal. What's that, folks? Negative 1 over 27, right? Yes, no? So this is what r cubed is, so what do I do now? Cube root, both sides. I'm sorry? Right, it's a cube root, so we can take an odd root of a negative. Negative 1/3, absolutely. 3 times 3 times 3 is equal to 27. We have r equals negative 1/3. Because we had r cubed, and we're looking for r. So how do I get rid of that third degree power? Because this is our formula, right? As far as to get from a to the second to the a to the fifth, a to the second to a to the third to the fourth to the fifth. At each step, exactly. R times r times r. It's the same thing as r to the third power. So now we have r equals negative 1/3. What did the problem ask us for? A6. So do I have to construct my formula for the nth degree, for the nth power? What do I do then? Absolutely. There's no reason here to come up with an. All they asked us is what is a6. And we know that's just a to the fifth times r. Or not a to the fifth, r fifth term times r. 2/3, okay. 2/3 times. So here we come up with our sixth term, negative 2 over 9. Questions? Again, this is pretty much the same thing as our arithmetic sequences, but instead of adding a difference, we're now multiplying by that common ratio. All right, folks.